in this short video presentation, you are going to see and learn about the ×5 foundational facts and how we can really use that multiplying by 10 relationship. Once again, you'll notice that this is very familiar from what we did with multiplying by 10. Give students a baggie of place value blocks along with a large, long, rectangular Post-it note or just even a piece of paper about that size. I would ask them to show me 4 groups of 10. What is the equation? 4 times 10 equals 40. Now, the next step would be what I'd like you to do is I want you to use that same model so that it shows 4 groups of 5 by using your Post-it to cover up part of that model. What do you notice? Oh, there's still 4 groups. How many in each group? 5. What's the total or the product? 4 groups of 5 equals 20. Now, what do we notice? 4 times 10 equals 40, and 4 times 5 is half as much, or 20. Now, you don't want to tell students that. You want to keep asking those questions like, what do you notice with your model? What do you see? How can we use 4 times 10 to help us solve 4 times 5? They're the ones that should be seeing the relationship. You're not the one telling them to see that relationship. Have them do another one, such as 7 times 10. Have them write down 7 times 10 equals 70. Now cover up that model so that it represents 7 groups of 5. They do that. They write the equation. We ask them questions so that they see that relation between multiplying by 10 and by 5. Once you do a few with them, you can say, I want you to do 3 more in the exact same way. I want you to record both equations that go along with that model for times 10 and times 5. Okay, now remember the games that we played when we learned about multiplying by 10? But now what you can do with your times 10 activities is switch them to multiplying by 5. So here is a very similar activity to what you did for multiples of 10. However, to get a little more bang for your buck out of this game, it's important that you have students engage in discourse that includes that relational thinking. If 10 times 8 is 80, then I know that 5 times 8 would be 40. And before they can place their counter on that spot, they need to say that discourse statement, or they can't place it. Really encouraging students to state that, because then as you're walking around listening to students play the game, you're hearing that relational thinking, and it's really a good formative assessment for you. We also played that multiplication war game for times 10. However, now students are flipping up a card and they're thinking about multiplying times 5. Once again, instead of them just saying 5 times 6 equals 30, I want them to say, if 6 times 10 equals 60, then I know that 6 times 5 would be 30, or half as much. Connections are key. Times 10 is so foundational for kids. I really sell it to them that it's the cheat code. It's the math hack, right? When they play their games, they use what's easy for them to get to those more difficult levels. Really market this to students. Recognizing what they are good at is so important because we can then really build on that. We can use what's easy to make those other things, such as times 5 perhaps, less difficult.